Now we have created the hub also. We can upload the code towards the controller, and before going to the code towards the controller, we have to go for installing the package. So go for sketch, library. In my system already it is installed. So this will be the particular overwritten. Now I have to install it from first. So that demo I will show it over here. Just type Azure. So here it is showing that it is already installed. Now select the required version and click on install. In this way only we have to install package for Arduino. So hereby we have seen how to create the particular hub, and at the same time we have also seen how to add the device and get that particular connection string. Everything we have seen over there. Now from this, let us start with a particular integration with NodeMCU towards Azure. So from Azure we will be sending the messages using NodeMCU through MQTT protocol. So hereby I am choosing one of the existing hub, whatever it is available onto this complete Azure part. So I am going for live IoT purpose. So inside this, here I have IoT device. So inside that I have created a device. Here we have to find only that particular part of the device. Okay, so this is the name of the device. Now inside this I have all the required connections and its parameters. Now what I am going to do means, so hereby I have that Arduino code. Now before going to the Arduino code, some applications should be changed. So like previously I have explained how to add that particular libraries inside the Arduino IDE. So go for manage libraries, and the most important part is Azure IoT Hub, Azure IoT MQTT.h. So these are all most important. So once again I am showing that. Just search it as Azure. So Azure IoT Hub. If you are going with HTTP protocol, you can go with Azure _ HTTP. Don't go for this Azure MQTT client. Go for Azure protocol -MQTT. So this is the most important. And for some cases we can also use utility, but not over here. So these three libraries are required. After installing that, go to the respective data path. So onto this data path, here we will be having that complete files. So go for local disk, users, Dell, app data. So Dell is nothing but your username. App data, local, inside that Arduino 15, go for package. We will be having the package known as ESP8266, hardware, inside that ESP8266, and the current version whatever you have, -3.0.2. Maybe some one or higher or lesser version you might be having. That's not an issue at all. So from that, here we have to go for platform. So inside the platform, we have to apply a function known as build extra _ flag. So the flag generation should be created like only ESP8266 should be used. We are not supposed to use upload to blob. So instead of that, we will be just using Baltimore certificate. So that is automatic online certificate which we will be able to collect from the Azure through this primary keys. So here we will be using this primary connection string only. This is only the most important part. So hereby I am copying that particular connection string. So after providing this command, this is the most important command, nothing to be deleted, only we have to add this command into our platform part. After that, click on Ctrl S to save the file. So after saving the file, you can just restart your Arduino. The Arduino IDE with this respective code. So from that, here we have many attachments. This is for sample input, where all the architecture of ESP8266 and ESP32 will be there. Then after that, go for configs. So we have to configure our NodeMCU. So what and all should be configured means SSID of the Wi-Fi PAN. So this password that also has been enabled. Now from this, the device string. So device string only, whatever we have copied over there, that should be pasted. I have copied the same device string only, so I am not pasting it over here. Then again give for Ctrl S, this will be saved automatically. Then come back to the main code as telemetry sample. So from the sample, everything will be enabled. So here what will be working means to send the data, sending the data from Node MCU to Microsoft Azure. The like hash include Azure IoT Hub.h, stdio.h, stdlab.h. Then comes with configs. Configs we are calling and sample init for ESP32 we are calling. Then ESP board we are calling it separately. From this MQTT protocol, then transport MQTT, that is nothing but publishing the data. Then HTTP to require with the web page service. So HTTP is also should be installed. Then here we are enabling our SSID and password along with connection string. So from that particular connection string, therefore the running continuously we have to provide it. So therefore the IoT hub connection will be continuously run based on the time whatever we have provided. So then message sent initially 0 and based on that the count will be increased. So that message will be known as telemetry message is known as test message. So from that each and every application like handling that cloud, handling the portal, so all that particular variations will be there. The same thing we will be just applying the static to send that particular message, and we should also receive the message as a result onto our serial port. Then only we will be able to verify whether the message has been sent or not. So from that here we will be able to get the message ID, and therefore the message ID will be printed. So from that, based on the array data, the messages will be passed as well as it will be automatically compressed and buffered into the cloud. So this portion belongs to that particular transmission part. Now finally, sending confirm. Whatever it has been sent, it must be confirmed over there. That confirmation process only this function, commonly said as connection status callback. So this is for common ESP board, let it be ESP8266 or ESP32. So for that common only here they have applied. And finally, all the functions will be called into the void setup as well as void loop. So inside the void loop, mostly only for 5 to 10 times it will be just connecting this particular hub. Automatically it will be shorting because unwantedly the message no need to be dumped inside the cloud. Now hereby we have that node MCU. So within that node MCU we are going to interface with the system interfaced. Okay, so COM4 has been connected. Now I am going to upload the code and simultaneously I am going to enable my Wi-Fi. So now the Wi-Fi is ready and I am uploading the data. Now let it upload and we will wait to receive the message in overview of live IoT. Click on overview to see that particular analytics. So here now we can see number of messages received and the cloud messages device to cloud. We are using D2C. How many devices connected, that also will be noted down based on the time. Let us wait till it gets uploaded. Now the code has been uploaded. Now just check whether the Wi-Fi has been connected. Yes, the Wi-Fi is connected. And to start with that functions, click on reset onto the pin. Make sure the baud rate is 1,15,200 and the now message has been started to send. The 5 messages has been sent. The packet ID, the message ID, everything is there. So therefore now the device is connected at this time also, and now you can see that total number of messages we have used for the per day. So here we can select that particular data according to which we need. Hereby go for 1 hour. So within 1 hour, this is the number of messages which we have received. In this way only we will be integrating this node MCU with Microsoft Azure. Total number of messages we have received in this channel, it is 19. In this way we can make the analysis of data. Thank you for watching our video. If you like this video, kindly click on the like button and share the video to your friends. Don't forget to subscribe our channel.